Roticon Engineering. Established in Durban, South Africa in 1979, Roticon Engineering still services the same industries today and has grown additional lines, namely a division making fasteners and rivets. We are currently designing and developing machinery to recycle cars, trucks and mining tyres. Roticon has more than 30 years of experience as a manufacturing engineering company. We have invested heavily in machinery and equipment, and today we remain one of the market leaders within the light to medium engineering sector. Introducing a new green energy invention, a two separate hydro system, each system providing the energy for the other to function, without any external energy input to keep it functional. HydroGreenGen. The design is a modular system, so depending on the electrical output required, modules can be banked together to increase the power supply. The HydroGreenGen invention contains a two-tube system, tube 1 on the right and tube 2 on the left. Both tubes contain fluid/water which are both equal in pressure. The tube system stands precisely at 25 meters. The lever system reaches a height of 5 meters, leaving the total height at 30 meters. This quarry shows us how the HydroGreenGen would be set up. The water is extracted from a local source such as a dam, a reservoir or lake. The water enters the pipe from the source and is released into the first reservoir. Once the reservoir has enough water for the system, it stops the intake from the source. The cam wheel is the primary mechanism in the HydroGreenGen. The water from the first reservoir runs down and travels through the cam wheel, which starts to spin. As it spins, the cable, which is a part of the cam wheel system, is put into motion. The cable is also a part of the pulley system, which is used to activate the lever. The lever system contains three main components: the drive weight, the piston, and the counterweight. The drive weight is pulled up and down from the strength of the cable's motion. This in turn causes the lever to move up and down on its pivot point, which is what allows the piston to function. The counterweight is on the other end of the lever, close to the pivot point, to even out the distribution of weight balance. The counterweight will also take into account the weight of the piston and allow for the friction loss when the piston and lever are in upward motion. As the lever moves in motion, the piston pushes the water in the tube 1. The area of the tube around the piston is larger in diameter than the rest of the tube to allow a more accumulation as the water is pushed. In tube 1, the diameter of the tube and piston is 1000 millimeters. The diameter for the rest of the tube is 200 millimeters. In tube 2, the area of the piston has a diameter of 500 millimeters, or half a meter, and the rest of the tube has a diameter of 200 milliliters. The water in tube 1 is pushed down by the piston. The water passes through a U-bend to ensure the water flows smoothly. The water moves up from the bend. The water, being pushed up from the bend, compresses the accumulator. As the accumulator compresses, it pushes the piston upwards. The water enters tube 2 through the control valve and then through a no-return valve. As the piston pushes up, the water pushes the no-return valve closed so that it does not backflow into the reservoir. As the water is pushed up, it also passes through another no-return valve. This no-return valve functions using gravity close to the disc and prevents backflow. The water that enters tube 2 comes from the 3 reservoirs in the system that run down from the top. The last reservoir circulates the water down, which then enters tube 2 through the 2 valves. When the piston pushes the water up tube 2, it outlets it back into the first reservoir, completing the cycle. As the piston moves up and down, the water pours out in spurts. When the water passes through the cam wheel and then through the second reservoir, it flows down throughout the output wheel. The output wheel is the component that generates electricity in the HydroGreenGen Invention. The water flows through and re-enters tube 2.
The weights that we've used suspended above the cam wheel are identical to this bar here. This bar weighs approximately 12.92 kilograms, and the weight we're going to use to drive the wheel is this bar cut into 4 parts. Each one of these weighs 3.41 kilos. The total number of weight is 10. And we'll demonstrate now how one weight of this will circulate the wheel and lift the weight up and down.
I just want to get a circuit breaker.
Go down lower. Go down just next to the wire.
Okay, there's a 4-meter lever. At the fulcrum of the lever is a piston that will push water down through the system and upwards. There's a spring-loaded piston here with 160 kgs weight on it. That's going to act as the water on the column above. And on the end of the lever is 1,200 kgs.